Sustainability and Construction in the School of Built Environment at Leeds Beckett University. Oh, someone's very helpfully started recording. Thank you very much. So, yep, so this session is being recorded, and we have a few speakers, a few presentations to go through. So the first one, I believe, sincere apologies if I do not pronounce your name correctly, but I believe that we have paper number 76, which is by speaker, which is Bashar. Is that correct? Am I saying your name correctly? Is that?
It's very much correctly. Yeah, thank you.
Fantastic. Right. So I think your presentation will just now play magically, unless someone.
Second, let me put the presentation on the share.
Hi, hello everyone. Thank you very much.
There we go.
My name is Bashar Taha. I am an external and part-time research student at the University of South Australia, currently based in Dubai. My research work is hosting mega event as a drive towards sustainable development, and the case study is Dubai Expo 2020. Today, I'm going to share with you part of the outcomes of my study. So hosting mega events such as Olympic Games, World Cup, and Expo is an opportunity for every city to mark its position globally and show its capability and readiness to host and deliver mega events successfully. The hosting city will benefit from boosting the economy due to expected large numbers of tourists and visitors during the event. However, hosting mega events places a massive demand on generating new urban areas, construction new building and facilities, and upgrading infrastructure required for the event. Therefore, it will require huge investment in capital expenditures to deliver the required mega projects in short period, which will stress the budgeting. So the main challenge in planning for hosting mega event is how to balance between budgeting for the delivery of the projects in short period compared to a normal development and ensure that the massive investment will be integrated in future planning, maximizing the benefit and address the demand of city growth and create new business opportunities. Well, this will introduce a benchmark and best practice for hosting mega event and legacy planning in a climate change stress world. This will be through providing information through a series of site visits and interviews carried out to collect the required data to provide the information related to the following: the governance model and sustainable plans developed by the Dubai government to deliver Expo 2020 and the legacy, and maximizing the environmental and socio-economic benefits of investment in infrastructure and urban planning, and ensure that the huge investment will not be redundant after the delivery of the event in short period of 6 months. The integration between event planning and long-term of planning for city growth. For instance, Dubai Expo site was carefully chosen to be part of future strategic plan for Dubai South urban area. I will also explore some of the major projects completed and were required for the event, such as the new metro line, the strategic tunnel for the stormwater, and roadwork network upgrade. So the governance model established by UAE government to provide the necessary legal, financial, and organizational framework includes the Hvac committee, which is responsible for the centralized strategic decision and overseeing the overall planning and delivery of Expo 2020. The Bureau is the executive arm of the Hvac committee, was in charge of overseeing and supervising the delivery of Expo 2020. Last is the company in charge of the operation delivery and timely reporting to the Hvac committee through the Bureau. As mentioned earlier, that the Dubai Expo site was carefully chosen to be part of the future development of Dubai South, and it's a mixed-use urban area, logistic, business hub, residential, and also close to a new airport, Al Maktoum International Airport. So the key sustainable drivers of Dubai Expo 2020, one of the major elements of this key sustainable drivers, that the legacy of Dubai Expo 2020 will reuse around 80 to 90% of building and facilities and infrastructure in the legacy. So the drivers, there are 6 main drivers: will retain Expo phase road and infrastructure, retain existing assets, and maintain key anchors, and also legacy phase and land use transformation, and promote green space and public space. So one of the major mega projects to require to deliver the Expo 2020 event and the legacy as well is the new metro line. And the new metro line was choose the alignment of the line was choose carefully through a multi-criteria assessment in order to maximize the benefit of the investment in the new line, which is 11 billion dirhams, UAE dirhams. So there were 4 or more alignment options were studies against certain criteria to ensure that the benefits of this investment in building a new line will continue beyond the event. Other projects is upgrading and constructing new road network to provide access to Expo site and cater for future traffic demand. And the cost of the project is 3.2 billion dirhams. Deep tunnel for the stormwater to serve Expo site and legacy and existing urban planning and the future development. And cater for the city growth as well was one of the projects executed during the short period. The other projects is the Dubai strategic sewer tunnel, which is in the design phase currently. Part of it completed, and however, most of the projects still in design phase. So it will cover not only Expo but also the city of Dubai and also future development. So in conclusion, Dubai Expo 2020 was the event planned with consideration to meet the requirement of event delivery in short duration, yet providing a lasting legacy. Maximizing the benefit from investment and address the demand of future development and growth of Dubai. Ensure integration between short and long-term planning provides the required tools for sustainable investment and in urban planning and infrastructure development. Also, it's worth noting that major event provided an outstanding opportunity to extend the existing railway network of the city, which is critical to support environment sustainable urban form of Dubai future by providing a public transport for the residents of Dubai. Other major infrastructure projects, such as upgrading network, the deep tunnel storm water, and the deep strategic tunnel for sewage tunnel, plan to address the demand for the event and also of future development of the city growth and address city growth beside the short period of the event. Thank you very much, and I hope you enjoy the session. Thank you.
Thank you very much for that. That was really interesting. I have a couple of questions, but what I think might be more efficient is if we were to watch all of the presentations consecutively and have questions at the end, because each presentation is about 8 minutes long. Is that okay with you, Bashar?
Sure.
Great, thank you. So I think, just find my notes. I believe that paper number 62 is next. There we go. There it is. Beautiful. Thank you. I'm not sure about anyone else, but I can't hear anything. Do you need to unmute the presentation?
No, it has to do with the sound of the recording itself.
Okay, right. Can anyone else hear it, or is it just me?
I could hear it, but it's a bit faint.
Okay. Is there a way of turning it up?
I've tried that. And
can I share from my end, because I have increased quality in that. Okay.
Okay, okay. Are you going to share it from your end? Sorry, I missed that. Yes, you are. Great. Thank you very much. Let's see if that works.
So do you mind to stop it, and you have to reshare. So I'll just guide you on how to share that. Once you click on the share button, okay, at the top right-hand side, you will see include computer sound. So kindly click on that include computer sound first before you start sharing the presentation. So that way we'll be able to hear.
I'm not able to find any option for sharing sound.
Oh, unfortunately, I don't know why that is.
I'll tell you what then, shall we move on to the next paper number 52, and while that's playing, perhaps you can find your sound button while that video is running. Is that okay?
I suggest, Georgiana, that's we should be doing. Let's move to 52, and maybe Shoaib can help in guiding the presenter.
Yes, that sounds good. Thank you very much.
Hello, my name is Dr. Keleme Emmanuel Ifeanyichukwu, presenting a paper on the assessment of the variation in the maintenance of Hvac component unit and its energy consumption. Hvac stands for heating, ventilation, air conditioning. The co-authors to this paper is Winston M.W. Shakantu and Mr. Keleme Victor Obin, representing the paper at the CIB International Conference on Smart Built Environments. The introduction. Hvac systems, why is it a concern? Why is the Hvac maintenance a concern? A proper maintenance of Hvac systems promises various advantages, which ranges from energy savings, decreasing the maintenance costs, prevention of hazardous condition, increasing the life of the Hvac equipment, and ultimately guaranteeing the thermal comfort of the occupants. For systems such as the Hvac systems, they are known to be multi-component systems. And in this case, its maintenance requires a well-planned maintenance decision approach that will help the maintenance officer or the facility manager take expert maintenance decisions. This is consistent with the observation of Ayonga et al. 2014. Hvac systems problems is traced to the fact that Hvac systems are configured from the basic types of components, such as dampers, fans, valves, and coils, and they are usually multiple instances of same type of components performing different functions in the system. Research has shown that an estimation of 10 to 40% of the energy consumption of the Hvac system can be reduced by removing faults timely. Consequently, there is a need to consider the maintenance of this component unit as it applies to energy consumption. This research is meant to cover the research gap because previous researches such as the one done by Wong in 2013 considered the maintenance issue in general with no particular emphasis on the pattern and the frequency of the maintenance of this component part of the Hvac system. As such, this research provides the link between the Hvac component maintenance and the energy implication with reference to hotel buildings. What is the aim of this research? The aim of this research is to assess the maintenance of the component unit of the Hvac installation with a view to establish and establishing the components which are often given or which are given less attention in terms of maintenance and their energy consumption implications. In view of this, the research method adopted was basically a survey research method, and the hotels in Owerri Municipal, Imo State, a total of 115 hotels were studied. The population drawn, or the respondents were drawn from the maintenance officers and the facility managers in the 115, and as such, the sampling technique adopted for this purpose is the multi-stage sampling technique. The research instrument basically was the research instrument was the structured questionnaire, and the results and the respondents, the data gotten from it were analyzed using XPSS version 20.0. A total of 390 questionnaires were distributed, with 342 adequately filled and returned, giving a percentage response of 87.7%. Proceeding from this research, the findings that were made are as follows. There is no planned maintenance of Hbse systems. With regards to the maintenance interval, maintenance is only carried out when there is a report of a fault. And in few places, in the few hotels where there are occasional routine maintenance, it was observed that the interval spans as much as 18 months in average. Regarding to the pattern of the maintenance of the Hbse system components, a breakdown of the common maintenance actions done in each component is as presented in the slide with us. For the chillers, it is observed that the inspection and adjustment of all the operating controls, lubrication of the vanes and the leakages and bearing, and the visual inspections of the chillers were the basic maintenance activities carried out. For the water pump, it was observed that the checking of bolts and nuts for tightness and tightening as necessary, checking of all the pump bearings and the lubricating with oil or grease as necessary, were the basic maintenance activities carried out in this. Common checks that was frequently done in the air handling unit include the inspection of all the air handling and the fan coils, which is like a norm applicable to most of the hotels checked. Also, with regards to the air cooling package unit and the precise computer air conditioning unit, it was observed that it's only cleaning, check electrical terminals and contact operations and contact tightness were the basic maintenance operation that is commonly done. Details of all the kind of maintenance operation carried out in other sections of the Hbse component is as listed. We can see the details of the maintenance operation done on the switchboard as well as the piping system. In view of this research thus concludes that the maintenance of Hbse systems is usually not planned and is only carried out at the demand or report of a fault, which is not a good one for that. Also, the most maintained components of the Hbse systems arranged in the order of severity or in the order of preference given are the chiller, the air distribution, the chillers, the ventilation, the pipings, and the unit and the switchboards. Therefore, this research concludes that a planned maintenance with shorter routine interval and a uniform maintenance attention given to the Hbse component unit will be a definite way towards checking energy wastage resulting from faulty Hbse component unit and the system at large. Thank you for listening and expect to hear your questions. Thank you.
Thank you very much. Fantastic. Right. we've got 2 more papers to view. Is it Nikunj? Have you got your paper, your presentation now ready to deliver?
Yes, I'm doing it now.
Oh, fantastic. Thank you very much.
I think so. Still no sound is there. So I'll share from my end.
Okay, that's great. Thank you.
Hello, I'm Nikunj Sanan. Is it audible?
Yes, I heard that. Yes.
Okay. Pursuing master. Hello, I'm Nikunj Sanan, pursuing Master of Science at the Indian Institute of Technology, Palakkad. Today I'll talk about our paper, Terrestrial Laser Scanner Analytical Modeling towards Effective Scan Area Planning for Damage Detection on Structural Members. According to the recent IBMS report, more than 137 bridges classified as a distress, so which will give emphasis on the importance of the timely maintenance and earlier damage detection intervention to extend the lives and serviceability of the structural system. In earlier time, the bridge inspection was carried out using manual approach, in which the expert was assess the damaged area using underbridge truck, and they'll give their subjective statement on the severity of the damages, and here they only assess the critical damaged area, not the whole bridge. But recently the non-contact based technology such as the terrestrial laser scanning is introduced, which will scan around a 320° in a vertical direction and 360° in horizontal direction and generate the dense point cloud is shown in the figure. So the TLS is the most common and widely adopted in the static condition monitoring, which will detect the temporal variation of the structures. But when we want to detect the structural damages in the millimeter level using LiDAR, it will be the most challenging task. Why? Because it requires a higher number and the closer points on the surface to accurately detect the damages. The numbers of points on the unit area of the surface is known as the density of point clouds. So the density of point clouds will be depends upon the different factors like atmospheric condition during the scanning time, object surface property which we are scanning geometry, also the scanning position from the surface, and also depend upon the instrument mechanism. So from these factors, only the one factor is in our hand, that is the scanner position from the surface. So that scanner position only will decide the density of the point cloud. Considering this factor, Laffer and the team has developed a fundamental mathematical model to analyze that how much minimum crack can be detected by the LiDAR on the unit-based masonry. In the another effort, Anil and their team has conducted a lab experiment to evaluate the effect of the scanner distance to detect the cracks on the concrete frames. In the related context, Cabo and their team has also proposed the way to find the best scanner position on the heritage. Very few studies have been undertaken by considering these factors. Also, these all studies have been carried out on the structural members other than the large and complex structures such as the bridge structural components. So in this study, we have did the analysis of the variation of the point density by changing the scanning location. So it will be useful to decide the effective scan location and the coverage area to detect the damages in the millimeter scale on the bridge structural components. The overall aim of our study is to accurately assess the preliminary damage on the bridge structural components using the LiDAR technology. To achieve this aim, our sub-objective is to develop the mathematical model which will be helpful to analyze the variation of the point density by changing various scanning parameters such as the location of the scanner, angular resolution. So the methodology of our study will go follow. First, we have decided the structural member, which is the abutment and the pier with the vertical straight surfaces. Then we have identified the most common factor influencing on the variation of the density, which is the location of the scanner from the surfaces. Then we have derived the mathematical equations using trigonometric equation, and then we did the analysis, and finally we have generated the interactive graph which will be useful to decide the scanning location and the coverage area. And at last we have validated all of our derived equation and the graph by conducting the lab experiment. While scaling the vertical straight surfaces structural components such as the wing wall, abutment and pier, we need to consider the point density variation on the two phases. First one is the phase which is perpendicular to the scanning axis of the TLS, that is XZ plane, and the second phase is which parallel to the scanning axis of the TLS. That is YZ plane. So first we have considered the XZ plane, which is perpendicular to the scanning axis of the TLS. So on this plane, along the LX direction, the horizontal spacing AH will vary, and along the LZ direction, the vertical spacing AV will vary. So to find these all interpoint spacing AH and AV, we have derived the equations using the trigonometric relationship, and then after we have generated this interactive graph. So here if the user wants to get interpoint spacing of 2 mm, then he need to scan along LX direction of 5.4 meter and along LZ direction up to 4.9 meter, and he can keep his laser scanner from 3 meter to the 10 meter. So if I'll conclude, then I can say that if I'll keep my scanner from 3 meter to 10 meter, and if I want a 2 mm interpoint spacing, then I can scan in the LX direction up to 5.4 meter and in LZ direction up to 4.9 meter. So effective area can be covered is 5.4 meter by 4.9 meters. So in the same way, we have considered the plane parallel to the scanning axis of the TLS, which is YZ plane, and here also we have derived that equations to find that horizontal and vertical interpoint spacing using the trigonometric relationship, and then after also here we have generated the interactive graph. So by using these graphs, the user can decide the effective scan area. To validate all of these derived equation and graph, we have conducted the lab experiment. So first we have conducted the experiment on the plane perpendicular to the scanning axis of the TLS. So for that we have taken a vertical straight grid wall, and then we have scanned that grid wall by varying this distance, and then we have taken different sections along the LX direction and along the LZ direction, and then on that section we have measured these all interpoint spacing values. So here we have measured the horizontal interpoint spacing on the Z section. So here you can see that on the Z section the measured value is 0.7 mm, and the calculated value using our derived equation is 0.63 mm. So that difference between measured and calculated value is in a fraction of the millimeter, which is negligible. So the similar way we have measured the interpoint spacing in the vertical direction, which is AV. Then we have compared. So here also we got interpoint spacing difference in the millimeter fraction. So that is also negligible. So similar way also we have did the experiment on the plane parallel to the scanning axis of the TLS, which is YZ plane. So for that we have considered this multi-purpose hole. Then we scanned these hole, and then we measured their horizontal and vertical interpoint spacing, measured value, calculated value, and then we had taken the difference. So here also we got that difference is in a fraction of the millimeter, which is also negligible. Now I will conclude by saying that the study shows that how the terrestrial laser scanner can be accurately used to assess the structural damages in the millimeter scale. Here also we have seen that how can we customize the data acquisition parameters. So by using our proposed point spacing variation equations and the interactive graphs, the user can decide the various data acquisition parameters, such as how much distance I'll keep between target and the scanner. So after locating my scanner at a particular distance, how much effective scan area I can cover, and at last how much angular increment I'll set in my terrestrial laser scanner. So in future, we will extend our study to find the point spacing variation on the circular cross sections. So here all are references I used, and at last, thank you for listening me patiently. If you are having any question, feel free to ask.
Thank you very much. I'm glad that worked eventually. We've got one more paper, which is paper number 77, and is Reem there? Yes.
Yes, hello.
Hi, thank you. Right, so I think your paper's playing now, actually. I can't hear anything though. Maybe this is a similar issue. No, I can't. I don't have any audio on that.
Can any other person hear? Because I've been playing it and okay.
I can't hear.
Okay.
I'm going to reshare.
Lovely, thank you.
Hello everyone. This paper is entitled By the Management of Recovered Wastewater for Passive Irrigation of Buildings Greenland.
Is it better now? Can you hear?
Yes, thank you.
Landscaped areas. Myself, Rimil Yaqub, Green Urbanization Manager of Polypipe Middle East, and my colleague, Rod Green, a Principal Public Health Engineer from Engineering Production Group, UK. We are the authors of this paper and hope you enjoy the content. Natural resources are the real wealth of nations. As we all know, Gulf Cooperation Council countries are poor in water resources. And in accordance to the United Nations, all the GCC countries, except Oman, fall in the category of acute scarcity of water. This means that countries have an annual renewable water capacity of less than 500 cubic meters per capita. The conventional water resources of the Gulf region include surface water, groundwater, and shallow and deep aquifers. However, non-conventional water resources come from desalination and wastewater recycling. While water resources are in short supply, demand for water is growing in the GCC countries. The question of the optimal management of water resources is clearly of crucial importance, with implications not only for the future development of these countries, but also for the sustainability of their past economic and social achievements. Recently, many Gulf regions have announced their long-term plans to determine the future development of their own countries, emphasizing on healthier and more sustainable objectives. These proposed visions incorporate common goals toward enhanced sustainable infrastructure, developed economy, improving a healthier environment and the quality of living, and lastly, the well-being and happiness of the residents. The limited existence of water sources in the Arab region is one of the major concerns facing sustainable development, as reported, due to many factors. The nature of the arid climate, for example, of the country, rainfall that has extremely irregular events in time and space. Finally, high temperature in the region leading to high evaporation rates that reduce the amount of surface water available. In order to assure the alignment with the announced future visions, public health plays a pivotal role that should be highlighted in many project schemes. Automated irrigation techniques, as sprinkler and tripping, have recently proven to assist in spreading infections through air, especially due to the use of TSE-treated water for irrigation, increasing the chances to get many infections caused by bacteria and viruses. Passive capillary irrigation is a method of growing plants and grasses using the natural process of capillary rise, driven by evapotranspiration, drawing water from the storage reservoir to active root zone. The hollow structure cones within the geocellular units are filled with the absorbent rock wall, which is the capillary cones, that draws up treated wastewater or rainwater. This attenuated system can be integrated into green podium roof design, and wastewater can be delivered and stored with the geocellular system to provide passive irrigation of the green spaces, creating amenity, recreation, biodiversity, and enhanced well-being.
In temperate climates, rainwater is more readily available for reuse. In arid regions, rainwater is not readily available. However, the practice of recovering and reusing wastewater, such as grey water, black water, condensate, and treated sewage effluent, is well practiced. The aim of the document is to investigate how a subterranean passive irrigation system developed for temperate regions can be adapted and developed for arid environments using predominantly recovered wastewater as the main source of irrigation. Our investigations commenced with a literature review which highlighted a considerable library of existing academic research for differing forms of irrigation, serving a wide variety of applications. From the existing research, it became clear that the instigation of live trials carried out in tandem with descriptive and numerical research would be beneficial to understand and support the hypothesis. Using live trials will enable a better understanding of the preferred soil conditions, wastewater treatment and regulation, the most favourable native plant species and grasses. All the above is necessary to ensure a well-designed blue-green passive irrigation system. The trials will also help inform health and safety benefits during both the installation process and ongoing maintenance of the trial beds. Developing blue-green spaces using recovered wastewater that provide economic, environmental and social benefits is integral to creating the visions portrayed within the long-term urban master plans published by a number of regional states. The hypothesis is complex, and with a more informed understanding of both micro and macro subterranean passive irrigation systems, it is probable that they can assist in realising the green visions as part of a wider water management system.
Right, thank you very much. So that's, I don't think we have paper 66. Is that correct?
Yes, we don't have it.
Okay, right. So that leaves us with 10 or 15 minutes for questions. So who would like to start? Does anybody have any questions about any of the 4 papers that we've seen? If not, I've got one. My question is, the paper that we've just seen is on the is on passive blue and green infrastructure in regions which have water scarcity but a high water demand. In the first paper that we saw, there was one of the slides was discussing a deep tunnel stormwater system, which was designed to address the demand for development of new urban areas and regeneration of future land. I'm just, there seems to me to be a sort of disconnect there between the outputs of the last paper that we saw and this, the opposite of a passive system, which was presented in the first paper. I just wondered if, Bashar, you could comment on that. Really, is there a reason that Dubai have designed this deep tunnel stormwater system? When there are more sustainable passive measures that could have been introduced.
Well, the purpose of the deep tunnel is to collect to increase the catchment area and collect the storm water from the city, different places of the city, and reduce the dependency on the pump stations and to use the gravity instead. So this is the main purpose of the deep strategic tunnel, instead of using the other types of collecting the stormwater. So ensure more catchment area and reduce the dependency on the pump station, the used pump station. So use gravity instead. So there is one or two pump station in the whole from this location. This is the Hbse side, and this is the red line. This is the tunnel where started from Hbse side. However, there are small I would say pipelines to serve the urban area and industrial and business hubs around, also the Hbse side. So the tunnel will go from this red line, will go towards the sea, and then there is a pump station to lift the water and throw to the sea. So I think there's one or two, I'm not sure. I need to check the resources. I need to check with the authority whether there are 2 or 1 pump station. So the main purpose is to increase the catchment area and also cater for the future increase in the expected drain and stormwater. Thank you.
Thank you for that. But better for the future, how? I'm a bit confused because the passive measures, for example, using a planted urban drainage system it is far more sort of future-proof than a heavily mechanized and engineered solution such as this deep tunnel stormwater system. So I'm just wondering what their interpretation of sort of being future-proofed is based on.
Future towards the development of the city itself, toward the growth of the city. So they are prepared. This tunnel is prepared to serve the city in right now and the future growth as well. So the design of the pipe itself was to cater the storm water and drain right now in the current time, and also for the future. I mean, the statement of the future is to serve the future growth of the city and population, and also the development in the urban area. But the mechanism itself, why they are choosing this mechanism instead of others, the point that I can refer to is to reduce the dependency on the pump stations and use the gravity instead. Okay, thank you. Mohammed, do you have your hand up?
Yes, I think those two papers raise an important issue, and it's how society looks at the issue of recovered water. I think anyone who visits that part of the world, the GCC, where it's very hot and desert-like climate, will be amazed of the green area. And professionals have been raising issue about, are we using water wisely? I think the question is probably to Reem. To what extent do you think society first and then the industry has embraced the concept of using recovered water and more passive solutions?
In Dubai, they use the even recycled water for the irrigation and for the plant in the city, and they use also the storm water in different purposes. Beside the desalination plants, they have many desalination plants from the power stations to help the to serve the demand for the potable water. They really good in terms of reusing even recycled water instead of not only the storm water. They use the treated recycled water for the irrigation system to help the landscape around the city, and also they use, as I mentioned, the storm water and the collected storm water and other options. I need to check with the sources as well. Besides, they use the desalination plants to provide the demand, to address the demand for the potable water. Thank you.
The question still to Reem.
Yeah, hi. Thank you so much for this question. Actually, I have to say that this is one of the main topics that the Gulf region, especially the one that suffer from the scarcity of water. For me and professionally, I work with, let's say, a firm that provides sustainable water management solutions. And I talk to consultants, I talk to governmental agencies or sites, or I talk to private owners, clients, many various stakeholders. Unfortunately, the main topic is still the reuse of water and the stormwater events. Like, I know for most of us all realize that, yeah, stormwater events, they are rarely presented in the Gulf region. However, when they occur extremely in aggressive ways. So this topic is not yet been resolved. And actually, this is depending on our last conversation with the municipalities in the region. At the same time, we have the issue of reuse of water. Like, yes, you have almost 20 desalination plants now in only UAE. So this is a huge number. And you're talking about energy consumption. You're talking about so many aspects and not just, one, let's say, concept of desalination water. No, you're talking about things that are more related as well to sustainability aspects. At the same time, or let's say, saying that, we have countries that depends on AC condensate, AC most of the time, and not most of the time, actually. I believe most of you know that it's about like 24 hours of AC use. You have the malls, you have so many communities that just produce so much water. At the same time, the use of this water is not just happen in a very, let's say, sustainable way. For example, one of the articles or reports that's published by DEWA, 60% of water is wasted because of the over irrigation, and this is like, it's a huge problem that's not resolved yet. So creating a concept that's originally came from the European regions, which is the passive irrigation mechanism, can help actually to provide sustainable aspects of the healthy green concept that we are looking for. So yes, Dubai 2040 plan, for example, is looking to provide more sustainable green communities. But what we want really is that a healthy green environment that is sustainable and that can actually provide more reuse and more, let's say, friendly concept to the community rather than just stay with the conventional irrigation methods that we all use. I am sure all of you went to public areas, public park areas, and you witnessed the use of conventional drip irrigation methods. I'm sure actually as well you noticed how trees are being sick due to the over-irrigation part, due to sprinklers irrigation, for example. And I am sure most of you actually noticed the fungal infections within the drip irrigation lines. And these are actually public health issues. So it's not yet, again, resolved. These small gaps within reuse of water, the sustainable reuse of water is not yet, again, resolved. And we really need to provide more research on it. To be honest, we are working on the technical side of this research now with our research institute. Hopefully to get more results out of it. And for sure, we can publish it in next paper ahead. And thank you. I hope I answered your question.
Thank you. Thanks very much for that. Do we have, is there another hand raised there? Sorry, I can't see your first name.
I'm the one, Hvac.
Hi, Hvac. Do you have your hand raised?
Yes, I do.
Okay.
My sort of maybe question is to Ifeanyi Chukwu on his paper. And what I want to ask is during the course of the research, did you find out maybe as a further line of research on how applying some sort of digital technology, artificial intelligence, how it can assist, the maintenance pattern of this Hvac system and the control system, etc. Thank you.
So
I can hear you. Hello. Can you hear me?
Yes, we can now.
Okay. At the course of the research, we were able to find out, though that it's a research in progress, but we are looking at the possibility of having automated systems that can prompt, that can beckon on people or can give signals to faulty components of the Hbse system. That's the drive, and that's where the research is tending towards, because most times you find out that the delay in notification of the faulty parts of the components of the Hbse system is as a result of, it's a product of early detection as well. So we are looking at that direction, and it's a work in progress at the moment.
Thank you.
Are there any more questions? We have a couple more minutes. If not, we can end the recording there. Thank you so much to all of the speakers. Your papers were really interesting. I didn't understand all of it, but certainly I understood a couple. Oh, got another question. Yes.
So it's not a question. I just wanted to quickly remind everyone that when we go for lunch break now, we resume back by 2 p.m. and we resume back to the day one opening session and keynote platform, where we first had the keynote addresses this morning. That's where we will be converging back to listen to the afternoon keynote address. I just wanted to remind everyone. Thank you.
Thank you very much for that. Reem, I've just uploaded into the chat a document that was published last year here in the UK that you might just find interesting. It might not be, but I've uploaded it just in case. You're welcome. So thank you very much, everyone. I'm going to finish the recording there.